Hello everyone, my name is Alexander. People refer to me as Sasha, but this requires a whole different presentation. And I am a developer at INT. One of the projects I worked with the gauges, and today I'll be talking about that. Today I will talk about some fundamentals which are absolutely required for you to be able to work with gauges efficiently and deliver the user interface and functionality which you need to which the gauges provide. So I'll talk about what the gauges are. I will display some fundamental concepts like gauge registries, which allow you to reuse gauges, some regions, which is a very important concept to understand in working with gauges. I'll talk about the function registries, handler functions, easing functions for animations which are supported. I'll talk about some alarms which allow for real-time monitoring and firing events when your values are in certain ranges. And then once you are familiar with the concepts, I'll go over the circular gauges, circular, numeric, linear, and traffic gauges, which are provided out of the box with our toolkit. So all of you understand the importance of data visualization, I hope. And in nowadays, where everything is moving towards the real data, is really important to monitor the current state of your values, the current data. And to raise to the call, INT developed a library of gauges, which provides a tool set to efficiently monitor and trigger some events or have a visual representation of what the current state of your data is, especially for real-time applications. It's a very lightweight tool, which is very simple to use. It delivers some API which allows you to create a gauge within a couple lines of code. It's like everything from INT, everything web-based from INT. The gauges are rendered on canvases, and we provide some API to highly customize the gauges to let you easily achieve, as easy as possible, achieve the UI for your gauges which you require. And I'm fairly comfortable to say that out of the box, gauges can supply 80 to 90% of the user interfaces that you want to achieve. It will require some creativity for some of them, and also please do not quote me on this. But the gauges are very easily styled. They support some CSS styling, also some standard GeoToolkit styling. If you worked with GeoToolkit before, you would know. We support animations, which make the visualization more fluent. Animation functions can be provided by the user and are fairly easy to implement. User can control the sequence, the order, and the speed of the animation. And the last but not least, the gauges support alarms. Unlike some people in this room, gauges will never miss an alarm. Alarms define a range of the value within which, if your gauge value falls within that value, a certain handler will be called and some logic will be implemented. It can be starting from changing the background of your gauge and going all the way to maybe sending an email or triggering some advanced functions. So INT provides four major types of the gauges. The first type is a circular gauge, and a circular gauge defines a data set which has a specified range that the values can take. The range is defined with the circular axis, and the specific value at the time is pointed at with the needle. The other type of the gauges is the numeric gauge. These are a bit more difficult to read visually, but provide more precise information because they render the value of the gauge with a number, and it's very as precise as the user wants. The traffic gauge is a bit different from other gauges because it doesn't represent the current value. Instead, it defines some ranges which the values can take. And whenever the value is within a certain range, a traffic light comes on. And the last, but the second most common gauge is the linear gauge, where as the circular gauge, it also defines a range which the values can take. But instead of going in a circular, it implements the primary visualization with a field, with an object which is filled to a certain position to reflect the current value of the gauge. The first fundamental concept which I wanted to talk about is the function registry. And function registries is a tool in the gauges library which allows you to create gauge templates. It's easy to create simple gauges, but sophisticated gauges with a lot of UI components can have a lot of code in it, and a lot of times you will need to reuse a gauge to display different data sets. And I think Usain Bolt said, yes, I'm lazy. There is no doubt in that. And that's why we created the registries where you can register a template of a gauge and then pull it and apply it to your data sets, and it should work out of the box like a charm. As I said, it streamlines the creation of gauges. It allows you to reuse the gauges and apply them to different data sets without having to recreate gauges every time. Since the definition of the gauge is only created once, your code is significantly smaller, and the maintaining that code becomes much easier. If you have the GeoToolkit libraries, you will automatically get a default registry which is already pre-filled with some gauges, and these gauges are implemented by our developers. The UI is already there. All you have to do is just get the gauge from the default library and apply it and connect it to your dataset. Here I will quickly demonstrate how easy it is to use the default gauges, and assuming that you register some gauges into the registry, and the procedure of applying it to a dataset will be exactly the same. So the first, you would create you would call the getDefault instance, which is a static method on a gauge registry class, and it will return you a new instance of the gauge registry pre-filled with everything that INT has to offer. Then getting the actual gauge implementation is as simple as providing a name of the gauge that you want to create and call the create gauge method. The toolkit gauges which are already implemented are provided in this namespace, which is GeoToolkit.JS, that default like template. And if you go into the documentation, you will see all the implemented gauges over there. If you create your own gauge, you would register it with a name, and then you would provide your name into this method, and you would receive the implementation, the instance of that gauge. And then assume that all the magic of creating a node is already done, and the root group is the root of that node in my case. And I'm adding the gauge to the scene, and I'm setting the value to 50. So this code is coming from an example application which I can share with you after the presentation if you want to take a look. And literally, this is 4 lines of code which leads you to this gauge. And so these are some of the gauges that exist in GeoToolkit by default. I'm actually switch to the live demo of this. Can you see it?
Yes.
Yeah. So these are all the gauges automatically defined. And you can get them out of the box. Just provide the name and use the registry to create them. This is in the documentation as demos Karnaugh gauge gallery. Okay. So another very important concept to know when working with gauges is the concept of the region. Every component of the gauge is rendered within some region, and by default, whenever you create a gauge, 9 regions are automatically created and calculated. These are some cardinal, some intercardinal regions, and the center region. Whenever you're creating a gauge, the only region which takes up the entire space is the center region. Because, and if you want to expand others, you provide the sizing of those regions. And by default, everything in a newly created gauge is rendered into the center region. I will elaborate on that a bit later. Function registries and easing functions is another registry, because we love registries. It's another registry in the gauges library which allows you to register functions and then call those functions from within the gauge without having to pass the bodies, because gauges never store the bodies of the handler function. This is instead the gauge stores a name which references the function from function registry. This serves a couple of reasons. The first is that the functions can be replaced, the handlers can be replaced in the runtime. Because gauges never store the bodies, gauge requests the function from the function registry every time it has to call the function, be it a handler, an animation function, or anything else. Since the gauge doesn't store the state of the function registry, once you replace the function registry, whenever the gauge retrieves a new function, it will be something that you newly provided. And important thing to notice here is that the primary goal, the primary reason we went with implementing function registries was to provide a proper serialization. Function registries being a site, an external resource for the gauge, ensures that no function bodies are being serialized and deserialized with the gauge. Instead, only the function names are stored, and you can plug in the registry later. Creating a function registry is as simple as instantiating a class, and registering a function is as simple as providing a name and the function body into the gauge. If a function doesn't exist, if gauge has a name for a function, the function doesn't exist in the registry, simply no function will be called. And the last fundamental which I wanted to go through today is the alarms. And alarms provide some advanced monitoring for your value. It ensures that you don't skip any critical position of the value. You can alarms allow you to define a range, and if the value falls within a certain range, the handler associated with this alarm is being called. And the handlers for the alarms, as every other handler in the gauges, are coming with the function registries, and alarms only refer to them by the names. And there are two fundamental basic types of gauges. Ones are axis gauges and others are numeric gauges. And the axis gauges represent multiple data sets within the same object. This is because of this architecture. In the descendants of the axis gauge, the alarms are set to each axis individually as opposed to the entire gauge. Even though the API exists to set the alarm on the entire gauge, what will happen internally, it will go ahead and set it to each of its axes and data sets. And if it's a numeric or linear gauge, you will just set the alarm to the gauge because it only represents one data set and one value at a time. So creating an alarm is easy. Just provide a couple parameters. It's important to know that we have a name here because later interaction with this alarm is going to be made over the name, by the name. The range defines the range of the values within which to fire the alarm. In this case, whenever the value is between 80 and 100, the alarm will go off. And we have the handler name, which is a user-defined function which will be fired with the value of the gauge whenever this alarm is fired. Add alarm to the axis gauge or add alarm to the gauge and let the gauges work the magic. So now that we understand the most fundamental concepts, I want to go into the particular gauges themselves and describe about how they work, what kind of components they implement. So as I said before, circular gauges, they represent a specified data range where we know the minimum and maximum of the data, or at least it's not changing as often. In the circular gauge component, in this particular example, you can see a bigger axis, which is the outer axis, and it represents a data range starting from 0 to 100. And we have two smaller axes which represents data from 0 to 40. Each needle, even these small triangular shapes are also needles. And each axis has its own needle where the needle represents the value of this gauge at the current time. Just to go through the structure of a gauge, you can see that we have an axis name, which is a title that you can provide to the axis. And each axis will have its title, and you'll be able to render this title in one of the regions, where you can place it on top of the gauge, you can place it on the side, or you can define your own regions. The regions can be placed anywhere within the box, and they accept CSS, standard CSS placing parameters. The value behaves exactly like the name, but it's important to keep in mind that the values can take unexpected turns. So the numbers, it's good to provide some handlers, some value formatters to handle unexpected values. The needles always rotate around the center of the circular gauge, and as I said, they point at the current value of the gauge at any given time. The axes are a standard vehicle to represent the range of the data, and the background can be styled with the fill style or line style. Circular gauge is the only gauge in the toolkit which comes with more than 9 default regions. And as you've seen this picture before, now let's assume you're creating a new circular gauge. This is what it's going to look like. But there is some more to it than just 9 regions, because a circular gauge automatically calculates 5 additional regions which are located within the smallest axis. The reason that we did this is these regions are always calculated so that they will not intersect with any label or any axis. You can display your gauge name, gauge value, or axis values within these regions, and you can be sure that this will never intersect with any labeling or the axis of this gauge. The only shape which will be able to intersect with this is the needle, if it grows from the center. Also, you can, as I said before, you can define custom regions, and the custom regions will give you an ability to integrate some custom components, any toolkit shape that you want, or even a toolkit widget if you want your gauge to be sophisticated enough. Well, let's go over some quick code of how to create a circular gauge. And I only provided code snippets to create circular gauges because it's very similar with creating other gauges. Here we instantiate a gauge, and the background property is just for demonstrational purposes, but it's very important to notice that we have a start angle and a sweep angle property. The start angle defines where your gauge starts, where your gauge arc starts its span, and the sweep angle defines by which angle the arc is spanning. In this case, the sweep angle is 2 pi, which is 360 degrees, so we have a full circle here, and you can see that the gauge is a full circle. But if you define any smaller sweep angle, the gauge would look like a pie chart, pretty much. And now let's go ahead and add an axis. A couple of things important to state here. First thing is an axis is defined by the name, and all the interactions with the axis within the gauge are done by the name. It's possible to retrieve the list of the axes to work with them. What we have here, what's very remarkable to note, is that we have the angle offset. And the angle offset is a concept which allows you to specify what is the radial offset from the start angle and end angle of the gauge itself, to which the axis will span. This allows you to manipulate the size of the axis within the size of different axes within the same gauge. And in this case, we have 20 degrees offset. And if this was a 0 degrees offset, your axis would also be fully circular as the gauge is. What I tried to display here is I tried to provide the name style and value style and set the display strategy to resize to fit. This display strategy tries to ensure that your text fills the region which it's within to the maximum capacity. And what it's going to demonstrate here is how the internal regions are rendered and calculated. And by default, whenever you add an axis to the gauge, your name will be rendered in the north region, and your axis value will be rendered in the inner south region. And now let's go ahead and add a smaller axis inside, and you will see how your text and values shrink because those regions also shrink. But keep in mind that this will never ever intercept the axis or its labels. Another important thing which needs its separate attention is the needle. Because we wanted to make the needle as customizable as possible, we went ahead and didn't implement needles at all. Instead, we are allowing the user to provide a shape which we use as a needle. Couple important criteria is that the shape has a defined bound where it has a width and height. The internal structure of the shape can be as the user wants, as the developer wants. And what's very important to have is to have a center point which will define where, around which point the pivot that the axis will rotate around, and the radius which can be relative to the radius of the axis which the needle belongs to, meaning that 100% needle will be touching the point of the needle will be touching the axis. And what gauge does is gauge tries to position the needle so that the center point that user provided is in the center point of the axis of the circle defined by the axis which the gauge belongs to, and it will rotate it to display the current value of the gauge. Another very common gauge that Toolkit provides is a linear gauge. As I said before, linear gauge is similar to circular gauge in the fact that they demonstrate a known range of data, but it's very different in the aspect that linear gauge only represents one data set. There is no way to connect a linear gauge to multiple data sets within the same shape. Gauges can be horizontal or vertical. Those are the only two layouts that are supported at this moment, and it has some main elements, which is pretty much a shape which is filled to a certain point compared to reflect the current value of the gauge. The axis is another important visualization vehicle of a linear gauge. You can add as many axes. These are standard GeoToolkit axes and can be numeric axes, can have any tick generators, can be color axes. And based on the layout of your linear gauge, axes can be added on the right or on the left or in the middle of a vertical gauge, or on the bottom or on top or in the middle of a horizontal gauge. This is one of the linear gauges that we have by default in our default gauges registry. And just to demonstrate, I will show you the components. So the axes in this case were added, one on the left and one on the right, and one of them is the numeric axis and one of them is the color axis. The indicator, so-called indicator, is the shape which demonstrates the full span of the gauge, and the fill is another shape which resembles the main shape but is filling to the location which corresponds to the location of the current value with the axis. The background is present in every gauge, and the value is also present in any gauge. But what's remarkable about this gauge is that it has a custom region with some custom text defined, and it also has some alarms where the regions match the colors that you can see on the color axis. Every time the color is within the green, the alarm fires a normal state which sets the text to good, Every time the color is within the yellow, the value is within the yellow, the alarm fires a threshold state and the text is changed to threshold. And every time it's in the red, the text is changed to dangerous. Or frankly, I don't remember what was the danger text. Luckily, I was in the green area when I was doing this presentation, so we'll keep it there. The last, not the last, the one before last is the traffic gauge. And as I said before, again, traffic gauge does not display the current state of the value. Instead, it displays which range the value falls within. And every indicator which defines a range is called a traffic light. And traffic light has two important properties to it. One is the active color and another one is an active color. Whenever the value is within the range handled by one of these indicators, the active color comes on. Every time a value leaves the indicator, the range defined by indicator, the inactive color comes on. The indicators are circular by default to resemble the traffic light, but you can provide painters to draw different shapes instead, and also very highly customizable. As you can see here, at this very moment, the value of the gauge falls within the region defined by yellow color and the middle indicator. And as previous gauges, they have a background, name, and a value. And the last one is a numeric gauge. I would say it's the most customizable of all the gauges because you probably guessed it, we didn't really implement this gauge. This gauge is more of an abstract concept which takes all the fundamental possibilities of the gauges and allows the user to define whatever the layout the user wants to display. It has alarms, it has custom regions, custom shapes, custom components, and allows the user to create something like this, where the gauge takes care of visualizing the current value, it takes care of layouting the components, it takes care of visualizing the name, also provides some API to place custom shapes around. But in this case, the look of the gauge is really left to developer's imagination. And as you can see from this example, this entire gauge is composed of a couple fundamental elements like background, gauge name, and gauge value, but everything else is custom regions, customly defined by the user, and the custom component in this case is a little triangle which displays if the trend of the value is going up or is going down. And this is another gauge which is provided in the default gauges that you can get in the gauge registry. So to recap what we talked today, is we talked about some fundamental components, fundamental concepts, gauge registries which allow you to recreate gauges and reuse them, function registry which lets you easily serialize and substitute functions during the runtime, some regions which allow you to position gauge elements in a very free manner, and alarms which allow you to monitor the state of the gauge at the current moment. Circular gauges which have a defined range, linear gauges also have defined range but only display one dataset at a time. Traffic gauge which doesn't display the value but shows a range which the value falls within, and a numeric gauge which is left to developer's imagination, can look however developer wants. And one thing which is very important to note is no matter what the primary visualization mechanism of the gauge is, as you notice, every gauge provides a possibility to display a current value with a number, where a general feeling about the value can be given, but the precise value can be displayed and read at any time. There are a lot of things which I couldn't cover today, a lot of other concepts that gauges implement, and you can gauges can work with CSS and can be styled through CSS like any other toolkit components. There are other concepts of regions within the circular axis. There are needles for linear gauges. There are different text display strategies, which you've seen one of them, which is resize to fit, but there are numerous others. You can format the value in a certain way. You can style the axis the way you want. But due to our limited time today, feel free to email me any questions about the gauges that you have. I'll be happy to answer them as soon as I have time. Thank you for visiting. Thank you for listening.